In question 44, we need to find the greatest length of an organ pipe open at both the ends when the fundamental frequency is in the normal hearing range. Solution 44. So velocity is 340 meters per second, frequency 20 hertz. So lambda by 2 equal to L, lambda will be 2L. So from here what you can look is that velocity is, or you can directly use this formula also, frequency is equal to velocity over 2L. So by this also you can directly do, or by this you can do any formula. So from here L will come out to be 8.5 centimeter for the situation when wavelength is maximum and frequency is minimum. And similarly, if you want to find for 20,000 hertz, you can also find that. In question 45, open organ pipe is given. We need to find fundamental frequency of vibration. What is the highest harmonic of such a tube that is in the audible range? Speed of sound is given. Solution 45. So now A part, so the frequency will be velocity over 2L, which will be 340 over 2 into 5 centimeter, that is 10 to the power minus 2, 3.4 kilohertz. And B part, if fundamental frequency is 3.4 kilohertz, then the highest harmonic in audible range will be 20,000 over 3400, that is 5.8, that is 5. So 5 will be there, 5 possible. In question 46, electronically driven loudspeaker is placed near open end of resonance column apparatus. Find the frequency at which the column will resonate. Solution 46. So here F0 will be V over 4L, 320 over 4 into 50 into 10 to the power minus 2, which will give us 100 hertz. And for odd multiple of harmonics, other harmonics which are odd multiple of F0, 2n plus 1 hertz will be there. In question 47, two successive resonant frequencies in open organ pipe are given. Find the length of the tube. So this is solution 47. So here the length of resonating column will be let it be L. So now two successive frequencies will be n plus 1 into V over 4L and V over 4L. So here it is given that this is equal to 2592 and this is equal to 1944. So let's subtract this 2. The subtraction will give us 548 centimeter. So this will be there. By this you can find. In question 48, a piston is fitted in cylindrical tube. Calculate the speed of sound in air of the tube. Solution 48. So L 32 centimeter, velocity unknown, frequency 512 hertz. So simple, velocity will be the wavelength. So we know the formula is this, v over 2L. So velocity will be f into 2L. So it will give us 328 meters per second. Remember, put length in meters, 0.32 meters. In question 49, a U-tube having unequal arm lengths has water in it. We need to find the length of air columns. Neglect any end effect. Solution 49. So according to the solution situation that we have, frequency equal to 3 into 330 velocity over 4 into length L2 first overtone, and the fundamental one 440 equal to 330 over 4L1. So by this we get L2 to be 56.3 centimeter and L1 to be 18.8 centimeter. In question 50, we need to consider this figure that is given here. The wire which has mass of 4 gram oscillates. We need to find the tension in the wire. Solution 50. So F0 will be 1 over 2L root T by M. Velocity is root T by M, tension over M. So for second harmonic, we will have 2 into F0, which will be 2 by 2L, that is 1 over L root T over M. So once we simplify everything, 85 hertz equal to 1 over 0.4 root T over 14. So from here T will come out to be 11.6 Newton approximately. In question 51, a long wire is given to us. Find the tension in the wire. Solution 51. So here let mu be the mass per unit length. It is 330 into 10 to the power minus 3 kg per meter. F0 will be 1 over 2L root T over mu. Let this be equation 1. And F0 equal to V over 4L, which will be 340 over 4 into 50 into 10 to the power minus 2, 170 hertz. Let this be equation 2. So from equation 1 and 2, we can easily find tension to be 347 Newton. In question 52, show that if room temperature changes by a small amount, the fundamental frequency of organ pipe will also change by a small amount, where del nu over nu is given as half del T over T. Solution 52. We know frequency is proportional to square root of the temperature F, or let's use nu plus nu del nu over nu equal to root del T plus del T over T. So after a bit of simplification, 1 plus del T over T 1 by 2. Let square root be there. So we will simplify this. This is 1 by 2. So by using the small powers, and we will only take up to half powers. and we will neglect the other terms. So 1 plus. So by this you can find that del v over v, 1 and 1 will get cancelled, half del t over t will be there. In question 53, fundamental frequency of closed pipe is given to us. What will be the fundamental frequency when temperature changes to 22 degrees Celsius? Solution 53. Again, frequency is proportional to square root of temperature, f1 over f2 root t1 over t2. So from putting all the values, f2 will come out to be 294 Hertz. In question 54, we have a tube apparatus. The powder collects heaps. We need to find the speed of sound wave in copper. Solution 54. So velocity in rod is unknown. Velocity in air is 340 meters per second. Length of rod is 25 into 10 to the power minus 2 meters. So and air column 5 into 10 to the power minus 2 meters. So V R over VA equal to 2LR over LA. So it will give us VR to be 3400 meters per second. In question 55, we need to calculate the speed of sound in steel and in air. Solution 55. A part. For this we have LR equal to 1 over 2.5 meter. Let dA be air length, that is 6.5 into 10 to the power minus 2 meter. Frequency VR over 4LR. It will be VR equal to 2600 into 4 into 0.5, which will give us 5200 meter per second. This is in steel, and in air we can find through this formula. In air we will be able to find the velocity to be 338 meters per second. In question 56, a source of sound is given. What is the frequency of tuning fork? Solution 56. So as tuning fork produces 2 beats, okay, so this means 476 plus 480 divided by 2, that is 478 Hertz. In question 57, a tuning fork produced 4 beats per second. What was the original frequency of the tuning fork? Solution 57. So it is either 256 minus 4, that is 250 Hertz, or 256 plus 4, that is 260 Hertz. Now as load is increased, so frequency decrease. Load increase, frequency decrease. So obviously this minus sign will be used, that is frequency will be 252 Hertz. Frequency will reduce. In solution, in question 58, calculate the frequency of beats produced in air when 2 sources of sound are activated. Solution 58. So in this particular question we have 2 situations. First is velocity 350 meters per second. In second situation also the velocity remains same. Wavelength in the first case is 32 centimeter and in the second case is 32.2 centimeter. So frequency will be 1093 Hertz. Frequency will be 1086 Hertz. So beat will be f1 minus f2, that is 7 Hertz.